paradox, a seemingly absurd statement or proposition that when investigated or explained may prove to be well-founded or true. There are thousands of paradoxes in this complex universe, and one of those will be explained today. Welcome! Today we're gonna learn about the birthday paradox with me, Zalfa Nurafirst, a mathematical student from State University of Jakarta. The birthday paradox stated this problem. Imagine a group of people. How big do you think the group would have to be before there's more than a 50% chance that two people in a group have the same birthday? Assume for the sake of argument that there are no twins, every birthday is equally likely, and ignore leap years. Pause here and try to figure out the answer by yourself. Okay, so you may guessing maybe about 50 people in a group or 100, but it's 365 days in a year. Maybe you need a half of that, so 183 people? The answer may seem surprisingly low. You just need a group of 23 people. With just 23 people in a group, you may share the 50% chance of the other person to have the exact same birthday with you. Meanwhile, this is a statistic from Pudding.co interactive website of people answering birthday problem. People barely answer about 60 people in a group, so that in that group, there's a 50% chance that two people have the same birthday. However, my answer was 177, which is so large and so far from the actual answer. With 365 days in a year, how's it possible that you need such a small group to get even odds of a shared birthday? Why is our intuition so wrong? Okay, from now on, be ready because I'm gonna explain to you the fancy math behind the birthday paradox. Because there are many ways you could get a birthday match in a group, trying to calculate the odds of a match directly is challenging. Instead, it's easier for us to calculate the odds that everyone's birthday is different. How does it help? First of all, let's imagine the odds as a box. We knew that the odds of a match and the odds of no match must add up to 1 or 100%. That means we can find the odds of a match by subtracting the odds of no match from 100. To calculate the odds of no match starts with a small group. Here's you, and one day of the year will be your birthday. So the odds are obviously 365 over 365, which is 1. Your friend have 365 birthdays to choose from, and 364 won't match yours. So the odds must be 364 over 365. When your other friend walks in, there are 363 possible birthdays left that don't match any birthdays already in the room, so the odds is 363 over 365. Now, another problem. How do we put these numbers together? When we combine the odds of independent choices together, we multiply their probabilities. So the chance that you, your friend, and your other friend has unique combinations of birthday with no one sharing is about 99.2%, which seems still quite logical for us. But if we add the person until 23 and continue to multiply the combinations, the result is 0.4937, which is 49% that no one shared a birthday with you. Back to the earlier equation, if we subtract that from 100%, we get 50.7% chance that two people share the exact same birthday. Now, we may dig deeper and try to find a formula for n people in a group of a birthday problem. As you can notice here, that the numerator is 365 times 364 times 363 all the way down to 365 minus 23, which is 343 in the case with 23 people. In finding formula for n people, this bunch of multiplication can be simplified to 365 times 364 all the way down to 365 minus n, and the multiplication of similar number continuously is definition of exponent in math, so it can be written as 365 raised to the power of n. We can still simplify this equation using factorial. Factorial is a multiplication of an integer and all the integers below it. We write the numerator to 365 factorial, but in this case, we don't want to multiply all the integers below 365 to 1. We stop the multiplication at 365 minus n. By that, we must divide 365 factorial by the factorial of the integer from n to all the integer below it, so 365 minus n factorial. Adding 365 raised to the power of n, and voila, we got the equation of birthday paradox for n people in a group. Using those formula, if n is substituted by 50 people, the odds jump up to 93%. If we add more people under 75, there's a 99.97% that two people in that group have a certain exact same birthday. It's almost 100%, means that if you are in a big classroom with approximately 75 students in it, there must be two people that born in the same day. This is a birthday paradox. It's one of the veridical paradox. It's surprising and absurd sounding, but we have the math to prove it's true. The birthday problem is just one example of a bunch of a paradox in this complex universe. By understanding it, we hope that we can improve our intuition better so that we can solve many problems that seems impossible at first to create a better future for our life.